Hey guys, okay, so this is Unit 10, and it's our first physics unit, and this is part 1. And so today we're going to talk about distance and displacement. We'll answer question number 1 on your notes handout in a second, but I just want you to think about this question. And this has probably happened to you. If you've ever been sitting maybe in the passenger seat of your parents' car or someone's car at a stoplight, and there's a big vehicle next to you, like a school bus or a semi-truck, and all of a sudden that vehicle starts moving, and even though you're not moving, you feel like you're moving. In that case, what happens is you picked the wrong frame of reference, and so we're going to talk about frame of reference on the next slide and answer question number 1. So question number 1 is, what is a frame of reference? And a frame of reference is a system of objects that are not moving with respect to one another. So basically, if you look at the 2 pictures on the right, a great frame of reference would be the tree. The tree is stationary. So if you were in that car and you compared your speed to the tree, you would be able to tell that you were moving. And this is why some people get motion sick sometimes. But a frame of reference helps you determine if you're moving or not, and in which direction did you move. Feel free to pause this video as needed to write down your notes. Here are 3 examples of frames of reference. So in picture number 1, your frame of reference is the trees outside, right? So they're whizzing by. So even though this is a stationary picture, I can tell that the train is probably moving fast. In picture number 2, you could look at the telephone poles because those aren't moving, or and it looks like the train is moving a little bit slower in picture number 1. And then in picture number 3, this would probably be a bad frame of reference if you were trying to determine your motion, because you're looking at someone who's moving at the same speed of you. So if you ever want to feel like your frame of reference or your speed is 0, pick a frame of reference that's in the moving object with you. And you'll see a question on the test about that. But basically, if you picked the seat next to you in a car, or the seat in front of you in a car or on a train, your frame of reference is making you seem like you're not moving because you guys are moving at the same speed. So it seems like a simple concept, but as you get deeper into physics and the years to come, frame of reference is important. Okay, so distance. Distance is the length of a path between 2 points. We measure it in meters. We use the metric system. So make sure to write down meters. And of course, any variation of that, kilometers, centimeters, things like that. But make sure you're using meters. Okay. Displacement, this is number 3 on your notes. Displacement is the distance in a straight line from your starting point to your ending point. Yes, this is a picture of the Hulk. I can't wait to go to Universal with you guys. So on a roller coaster, if you're in a car that comes back to where you started, your displacement would be 0, because even though you traveled a distance, you came back to your starting point. So your distance from where you started to where you finished is 0. So displacement is another concept that we'll practice determining, but it's pretty easy to understand. Okay, so here's a quick activity that I want you to do on this little section of graph paper. So you're going to draw a dot somewhere on that grid as if you were graphing. And then you are going to draw another dot somewhere on that grid. And then you are going to trace along the lines. Don't make a curvy path. Make like some sort of path, and don't make it too complicated. Make a path on the grid. Feel free to pause it here. But I want you to draw a path from your start dot to your end dot. Okay, so you don't really necessarily need a ruler because these are square centimeters on this graph paper. So what you're going to do is you're going to determine how long your path was. And then you can use a ruler, and that's when you can really determine your displacement of your path. So I'm going to go on to the next slide and show you an example of mine. So here is what I did. So if I were counting this, let me get you a different color ink so you can actually see what I'm doing. I would say I went 1, 2, 3, 4, 5, 6, 7, 8, 9 would be my distance. But if I took a ruler and I did this, I would be able to get 5 centimeters as my displacement. So even though I meandered, my displacement would be shorter, and that's oftentimes the case. If this was confusing to you, don't stress, because we will talk about this more. We will practice this more for a couple days. But this is kind of how physics goes. It's not too complicated. Here we go. Especially, and I like that you can see it. All right, so sometimes you have to combine displacements. You've got to add two distances together. And this is where the idea of a vector and scalar measurements come in, okay? So a vector is a quantity that has magnitude and direction. So if you remember Vector from Despicable Me, he has magnitude and direction. So it's an amount, and it's going in a certain direction. A scalar quantity is just an amount. It doesn't have a direction. So if I just said 5 miles, okay, that would be scalar. But if I said 5 miles to the east, that would be a vector. Vectors are always represented with an arrow. So sometimes, like if I said 4 meters, and I drew a little arrow over it, that would represent that that's a vector. So it's 4 meters and it's got a certain direction, and that will be told to you in the problem. So scalar doesn't have direction, vector does. So make sure to answer questions 5 and 6. Okay, so when you have directions in a straight line, it's pretty straightforward, especially if they're going the same direction, no pun intended. So if you look at cars at diagram A, this car traveled 4 kilometers to the right, and then it traveled 2 more kilometers to the right. So that's easy, 4 plus 2, and that gives you 6, okay? Now, when you've got two vectors that are in opposite directions, you've got to subtract. So this car traveled 4 kilometers to the right once again, but then it traveled back the opposite direction, 2 kilometers. So 4 kilometers minus 2 kilometers equals 2 total kilometers of displacement. Now, its displacement in picture B would be 2 kilometers, but its total distance in picture B would be 6 kilometers, because 4 plus 2 would be 6. So these are the types of problems we're going to be solving very soon. All right, so sometimes, and this is kind of what I showed you in that picture that we did earlier, sometimes displacement isn't along a straight path. Sometimes we've got to get the resultant vector. And I'm just going to kind of introduce this topic here today. And those of you who are in geometry, this will come easy to you. But we use the Pythagorean theorem to get the resultant vector. So that's kind of cool math. I feel like the purpose of math is to help us understand science better. So it kind of has a purpose. So here's what happened. The boy walked a total distance of 7 blocks, and if you count the yellow lines or the yellow blocks, that's how we get to 7. So that's his total distance. But what was his displacement? How far was he from his original starting point in a straight line? So to calculate displacement, you use the Pythagorean theorem. So this will be number 8 on your notes. So you're going to write down this Pythagorean theorem, and we are going to practice this more, so don't be worried. It's super easy. But there you go. A squared plus b squared equals c squared. So you use the sides of the triangle, and you can come up with the displacement. All right, so try to answer exit ticket number 1. Feel free to pause me. Okay, write down what you think your answer was. All right, the correct answer is C. All right, read this question and write down your answer. Okay, the correct answer is also C. All right, exit ticket number 3. The answer is B, because it's distance and direction. Displacement is a vector, so the answer should be B. Okay, so this one should be B. This also should have a direction. So 30 minus 10 would give you 20, and you are west of your home. So that's why it's B and not A. All right, thanks so much, guys. Go on to the next video. You're going to practice those problems on the next page.